All right. Can everybody hear me? OK, great. Welcome. Thanks for coming. I'm really stoked to talk to you guys about IndexedDB. And we can get started. A little bit about me. My name's Carmen. You can follow me over the interwebs. I'm Karma Lou. That's my Twitter and my blog. Sorry. I'm also in the Techlahoma Slack as Karma Lou, so if you have questions about this presentation or anything, please hit me up after. I have been interested in offline for a really long time, and this Margie map that's listed is actually a map to show income in relation to public libraries, because there's a pretty strong correlation between internet access and income. So definitely check that out. I'm really stoked about it. And I'm just going to jump right in. The biggest problem that I think IndexedDB is going to help with is the fact that internet access is incredibly unreliable. Has anybody in here ever lost their internet? I'm really surprised everybody's not raising their hand. There's a whole bunch of reasons why your internet is unreliable. The common issue we see here in the United States is this concept of intermittent connection. So we know what intermittent means. Sometimes you have connection, sometimes you don't. And the really big problem with this is the intermittent part of it is really completely beyond any one person's control. And everybody is going to lose connection at some point or another. Inevitably, it is at the worst time, right? I don't know about you guys, but that's how it always seems like it goes to me. So obviously, there's a whole bunch of different ways we can lose connection. I'm just going to briefly go over these just to give you guys some concrete examples. If you're traveling for work, maybe you're even just commuting to work, and you lose your connection, or you're traveling to a remote location and you lose connection when you get there. It could be both. If you are having some issues with your service provider and maybe they have too many customers, they don't quite have the infrastructure to support, so you end up with really slow load times, maybe you have drops, maybe it's even a hardware issue on your router. If you're a business, maybe your cloud service provider has to go down for some routine maintenance, and maybe it's during your peak business hours. That's not good. Nobody likes that. And then I already mentioned, this is probably the most difficult one to combat. I also think that it's where IndexedDB and other offline techniques are the hardest hitting, is this economic disparity. Like I mentioned before, there is a really strong correlation between income and a lack of internet connection. Maybe somebody isn't able to pay their cell phone bill, and that's their one way to access the internet. Suddenly, they just can't access the internet. And that's a really big problem. So we have a solution. We can cache data client-side. What does this do? We don't have to make requests over the network anymore. Everything is already on this person's machine. There's a couple different ways we can do this. The first, probably oldest one, is cookies. They are pretty easy to access and add. Unfortunately, though, they come with drawbacks. Namely, they have really low storage capabilities, usually only about 4 megabytes. They also will increase your overhead on AJAX requests. And they can't store complex data. What I mean by complex data is, let's think for a second about when you make an API request. You make a GET request, and you get back this, maybe it's an array of a bunch of objects, and maybe in the objects you've got even nested objects and arrays. That's what I mean by complex data. A cookie, you're storing it in a string. You've also got to parse what you're looking for out of that string. So it's more overhead, and it's just for small things it might be OK, but it's probably not robust enough for caching API requests. Our next option is session storage and/or local storage. They also have ease of use. They've got this really nice object notation where you're able to just add things with a key value pair. And that's really nice because it offers you a description of the chunk of data that you're saving. Unfortunately, these also have really low storage capabilities. Between the two of them, you're only able to store about 10 megabytes, which is not a lot of space. Session storage specifically doesn't have data persistence, so if you close your browser window, your data is gone. Local storage has a little bit better persistence, but it's still really short term. If you clear your cache, it's gone. Additionally, part due to the very low storage capabilities, part due to the fact that you're storing strings, you're not really able to store complex data like what you would get off of a GET request. A next option, which came after those previous things, is Web SQL. It's built on SQLite, which was definitely a step in the right direction because that gives you a relational database, which allows you to store that complex data we've been talking about. The downside of Web SQL is that it required SQL knowledge since it was built on SQLite. Not a lot or very many front-end developers have that SQL knowledge to be able to easily utilize Web SQL. It does not return JSON objects, which is kind of what we're expecting. We make a GET request on our API. We're expecting a JSON object back, so it would be really nice if where we're caching that data gives us the same thing back. It's not going to. It's going to give you back a more SQL sort of thing. And because of those things, Web SQL is actually deprecated. It did never actually make it into the JavaScript spec. It was deprecated in favor of IndexedDB for a couple of reasons. So we can talk a little bit about IndexedDB real quick and what it actually is. It has really great browser support. It's supported in Firefox, Safari, Chrome, Internet Explorer. There's one I forgot. Pretty much all your major browsers support it. It has really solid mobile support as well. You're able to save that complex data we've been talking about, and it's also saved in a JSON-like format because IndexedDB is more like a NoSQL than your typical SQL relational database. It offers you data persistence that cookies, local storage, session storage, those just haven't been able to offer you. So if you are utilizing IndexedDB and you clear your cache, you delete your cookies, it's still there. It also has higher storage capabilities. I tried to find like exact numbers on what each browser allows, and kind of what I found was that there aren't necessarily limitations. Like there's limitations from the file system, but like the browser itself isn't really putting any limitations on IndexedDB databases. So now we can jump into the structure of an IndexedDB database. I mentioned that it is more like NoSQL. So rather than tables, we've got these things called object stores. Rather than columns, we've got these things called indexes. Key path is kind of similar to a primary key, if you're familiar with that. And you can auto-increment. If you're familiar with SQL, you'll probably know about transactions. We can kind of jump into these things. So like I mentioned, instead of tables, IndexedDB uses object stores. Your object store is going to mirror what your object would have looked like if it had come from your API. So if the property names are going to be the same. You're going to have the same number of them. A IndexedDB database, it can hold multiple object stores. So it's like holding multiple tables. It's a way to group your similar data together. And the main difference that sticks out to me is that where in a SQL database, you're storing your data in a way that maybe isn't like it's going to show up in your web app. What you're going to do with an object store is you're going to group this data the way it would be viewed in your web app. And we'll look at that a little bit more as we go on. I mentioned indexes already. These are pretty similar to columns. They are the property that we were talking about. Like your object store holds the same properties that your response would hold. Indexes are what those properties are called. And they don't have type requirements. That's the thing to keep in mind. So a key path is what it must be unique. So when you are looking something up in your object store in your IndexedDB database, you'll probably look it up by key path. It's designated as unique, and you can look up the record directly. We want to do it this way because IndexedDB doesn't offer where clauses. So if you're familiar with SQL, you can look things up directly by doing a where clause. This is how you would do it in IndexedDB. So for example, if you had an object store of users and your usernames were all unique, you could make username your key path. And don't worry, we're going to see some code examples, so this will kind of start coming together. You would make username your key path, and then you could look up, if Carmen were one of your users, you could look up Carmen directly. You can also auto-increment. This is pretty similar. You can use a key path and auto-incrementing together to get something pretty similar to an auto-incrementing primary key. This will make this property always be a number, and it'll always also be unique. If there's any people who are familiar with SQL in here, you're probably going to think transactions look really familiar. They are. It's the same concept. It allows you to maintain the state of your database in the event that one of your changes fails. So all of our changes are taking place within a single transaction. One of them fails, the database doesn't change. So we're going to see an example of that kind of soon. IndexedDB is asynchronous. So how it solves this issue of JavaScript being single-threaded. So we do something, we need to wait until it's done before we can do the next thing. It solves this with events. The really common events that you're going to see through here are complete. So that's like if your transaction is running, it's going to throw an onComplete event when it's finished, and you can attach a function to that to carry on with the next thing. You're going to see onSuccess and onError. Those are probably pretty self-explanatory. OnSuccess is what happens if everything worked like it should. OnError gives you some error handling. The other one you're going to see is that first one is it's on upgrade needed. That one is where we're going to define our schema. And we're going to see that pretty soon. But before we jump into code, yes, Vance? So the question was, how does upgrade needed work, and how do you call it? Is that the question?
What does the event mean? The meaning that you need to upgrade the version of IndexedDB,
So we're going to see this in a little bit. I'm sorry. No, you're fine. But just to quickly answer your question, when you define your database, you also define it with a version number. And so what's going to happen is it's going to check against that version number on the client's browser. And if they don't have that version number, it's going to trigger that on upgrade needed event. So exactly. So we can talk real quick about what should we really store client side, because I don't know if anybody's thinking this, but this is a question I get a lot, is what is the security of IndexedDB? And to answer this question, is it secure? No. I wish there were another way. Your data is not encrypted automatically. So if you are storing data and you are not like manually encrypting it, and what I mean by that is like you have a function set up to go ahead and encrypt your data, it's not going to be encrypted. It's going to be sitting there in plain text. You can encrypt it, but again, that's something that you're going to have to do as a part of your process. The downside of encryption is if you're planning on using the plain text to search, it's going to interfere with your search abilities, so you're going to have to decrypt it. This brings us to the next thing. Is it accessible? And I don't mean, I mean like, can people get to it? Can they access it? Kind of. So IndexedDB is going to follow the same origin policy. So what that means is, like, my blog is carmelou.com. If I have an IndexedDB on my blog and I try to access it from facebook.com, it's not going to be able to get that data that's on my blog because it's not from that carmelou.com origin. Additionally, we're not able to copy data across browsers. So if I have something set up in Chrome on my blog, I'm not going to be able to get that out if I'm in IE. This is the kicker, though. If the user is messing around in DevTools, they can absolutely get to all of your data. Well, I guess technically it would be their data. The big point where I think this comes into play is if it's like a public computer. And so say you're like at a library and somebody has gone into an application that uses IndexedDB, any data that has been generated by that application and saved into that data store is accessible to any user. Yes?
So how can a user clear IndexedDB transports?
The question was how can they clear them, and when, I will show you this in a little bit, but when they have DevTools open, there are options for refreshing and actually deleting the database. So that would get rid of your data. You can also, if you are like concerned about like this data should only live for so long, you can delete it programmatically as well. So we're gonna get into those things. Just a couple of quick use cases. This is a documentation platform for service workers. It's available offline. This is more tech documentation. It's also available offline. And then if anybody's ever used Google Docs or Evernote or that sort of thing, what that's doing is it's caching your input as you're typing without necessarily making a network request. So if your network drops for some reason, they can sync it when your connection comes back. So let's jump into some code. And this is what you guys have all been waiting for. So when we initialize a database, it looks pretty simple. To Vance's question earlier, we are passing in a string, and then we're passing in a number. That number is our version number. So if we were to make schema changes, so that might look like, oh, we need a new object store, we would increment that version number. And that would trigger this on upgrade needed event, which is where we create these object stores. So it's all event driven. You get an event back in your function, and that is like a reference to your previous action. You can put these into global variables and have access to them. That's not really what I did in these examples. In this way, that's only going to live within that function, and once that function is garbage collected, your connection is also garbage collected, which there's pros and cons to that. So first thing we're doing after we open our database, define a version number, is creating these object stores. The next thing we're doing is we're creating these indexes. So you specify the object store, you do create index, and then you name your index. And you'll notice that there's an object, and there's some specifications about whether or not things are unique. If it's unique, then you're not going to have more than one of those records in your database. So if it was like a name record, I'm Carmen, there would only be one Carmen. If it's not unique, you can have duplicates, and it's not a problem. You can also specify that auto increment in there. Remember from before, that was one of our options. So you could specify auto increment is true. So now that we've defined our schema, we can go ahead and get started doing stuff. When you're opening a database, it's the very same method as when you created it. You just drop off the version number. So what that's going to do is that's going to look in your user's machine and say, open whatever version they have. If you wanted to close it, it's pretty simple to close it. You just have that reference to your database. You close, and you have events for that. So we can get into some CRUD operations. If we were going to create a new record, we would have those properties of this new trooper function method. I'm so sorry. It's not a method. It's an object. I'm pretty bummed that nobody's laughing at my jokes that are in there, by the way. I'm really, really sad about that. OK, so we generate an object. Its properties are going to exactly match the properties in the object store that we're going to insert it into. If they don't exactly match, we're going to get errors that those indexes don't exist. So once we've created our object, we reference the database. We create a transaction. We need to specify whether it is read-only or read-write. Read-only is the default, but if you're trying to do like puts or creates or anything like that, you really need to specify read-write. Trust me. you're going to specify your object store. This may look like a little bit of duplication where we've got transaction, we're specifying an object store, and then in object store, we're specifying the same object store again. The reason for that is you can actually have a transaction for multiple object stores at a time. You just pass in an array of strings for that. So that is why that's that way. And then the add method, you can see, you just call it as a part of that transaction, and you pass in your record. Reading a record is a little bit shorter. You've got your database reference, you open your transaction, specify your object store. You can do a get, so that name, that string, that's our key path. So if we had something that wasn't specified as a key path, excuse me, sorry. If we had something that wasn't specified as a key path, we wouldn't be able to look it up directly in this way. So you have to specify something as a key path to be able to do this direct lookup. And then you'll notice we've got an onSuccess function. If we want to update a record, it's pretty much the same scenario. Transaction, specify your object store. We're going to do a get. And again, you've got to have that key path to be able to look something up directly. That's going to return an onSuccess event when it's completed, which allows us to have the record to be able to change it. We'll do any changes in that onSuccess function, and then we'll go ahead and update it. Somebody didn't like that. That's saying you need to have those event handlers for your error checking. Anyway, deleting a record, pretty simple. We are, again, referencing our database, opening a transaction, specifying the object store, and we're just going to say delete. Again, like I can't stress the key path part enough. You have to specify a key path. If we wanted to get all of our data, we don't need a key path for that. So we're just going to reference the database, transaction, probably getting a little monotonous with that, but it's all really similar in that way. That getAll method is going to return everything that's in your data store, everything that's in that object store in your data store. If you wanted to delete an object store, you would use that clear method. If you wanted to delete your database, this is how you would just do that programmatically. You just call delete database, and then you pass in the string. You don't even need to have it like a transaction or anything. It'll just get rid of it for you. So we talked before about how there is not a where clause in IndexedDB. So my thought was, okay, how the heck do I search this thing? Because doing a get all and then filtering through the records, every single record, that sounds crazy. It's really memory intensive. Probably not a good way to go. IndexedDB has provided us this open cursor method. So what this is doing is it's still iterating through each record, but it only has one record in memory at a time. So if you find the record you want, you can stop your search once you've found it. It also offers this bound method. So this will allow you to narrow down your search. So if your search criteria was like a string, you could say only search A through F. And that'll give you a more narrow amount of things to search. And like I mentioned already, you've only got a single record in memory at a time. So it's not like you're doing a get all. You're pulling like everything into your memory and you're filtering through it there. This is doing one at a time, so it's more performant. So if we wanted to search for people who have access to our trash compactor, this is how we would do it. So we're initializing a transaction, just the same way we always do. Everything always has to have a transaction. We're specifying our object store, and then we are specifying that request to be that open cursor method. Its onSuccess method is going to be called for each record. It's looping. You don't see that just by looking at it, but it is looping. So each if statement is a new record. When we get into the else, that's when it has finished looping. So if we wanted to do something like only give me the people who have access to the trash compactor, that's how we could do it. We could grab that record as we find it and push it into a different array to have access to it. If you wanted to search for something that's unique, so if, say, there were only one person who had access to the landing strip, which seems pretty unrealistic because that's like a pretty big job to run. This is how we could do it. We're still opening our cursor. You see we've still got that request, open cursor. It's still iterating. But the difference here is since we know that it's only that one person who has access to it, we can go ahead and return once we've found them. So that'll just stop your search and be a little bit more performant. I mentioned bounds. So if we were only interested in stormtroopers whose names begin with A through F, we can specify that bound. That's that first line. Then again, transaction, specify the object store. You pass that bound into your open cursor. That's what tells it, these are the only records that I care about. You can run any checks on it in your if statement as it's iterating through, and then in your else statement, that's what it will fall into when it's finished iterating through those records. So I kind of fibbed a little earlier when I said you can only look up by key path. So if you're looking something up directly, you do have to have that be your key path. If you have other data that is not your key path because maybe it's not unique, like, what was the example? Sorry, I jumped ahead. Of course, it's going off the screen. So what you do here instead is on your object store, you're not specifying an object store, you're specifying an index, which I don't know if I can get that to scroll over for you guys. I'm sorry. You're specifying that index. I think the one I used here was favorite color. So like you wouldn't make a favorite color be unique because people can have the same favorite color. So that'll pull in that index or column is kind of what it's similar to. And then it's going to iterate through those, and that's going to be your key. So you can use that in this if block. And on that note, we are on to some demos. This over here. Okay. Actually, you know what? Let me just turn on mirror displays. Okay, so I'm going to follow directions and open up the console. Can you guys see that? Okay. This is a really simple example of a way you could go ahead and cache a form if you were to lose internet access. So we're going to type, it's a fake email address. So what we're going to do now is we're going to turn off the Wi-Fi. Oh, yes, certainly. Is that better? Yeah. Okay, thank you. Is the console good too? Yes. Okay. So what we utilize there is Navigator online. It actually was Navigator offline. What that'll do is that's going to pull for your internet connection. It has events for online and offline. It's really, really handy if you are worried about your connection. You can handle for when someone loses connection and when they regain connection. So what we did is we cached the data since we lost connection. We can pop over into here. Someone asked before how a user could get rid of their data. This is how. So we've got that delete database button right there. So just something to be aware of. This is our email object store, and that is here we go. This one is the one we just added. So if we were to turn the Wi-Fi back on, we can actually go ahead and do that and see. Okay, it goes ahead and retrieves the data, so it's ready if we wanted to, at that point, make an AJAX request. I can show you guys what that code looks like real quick. Can you guys see that? Okay. So this is our cache data method. We've got that temp object those properties exactly match the object store properties. We go ahead, when that cache data method is activated, which is when we lose connection, we can go ahead, open up our database, add the object real quick, and then it's there for when we need it. The get data method, which is called when we regain connection, really similar. Open up the database, just go grab everything, and then it's there if we need it. So in the get data method, that's when we would go ahead and do our AJAX request, because that's when we've regained connection.
What do you use for the detection of the connection?
I'm sorry, can you repeat that?
What do you use for the detection of the connection?
I will show you. The question was, what do we use for detecting, gosh, rhyming words. It is this event right here. So offline and online actually have events as a part of just the JavaScript spec. So you can attach functions to those events, so when they fire, these things will happen. Okay, so this is the one I was actually really, really excited to show you guys. Okay, so here's our scenario. This one's a little different. What we have here is we leave it in the user's hands when they want to sync the data, pull the data down, change it around, any of that. It's different trains of thought, right? In some cases, you'll want to be checking for connection and doing it behind the scenes. I would recommend that for like smaller amounts of data. If we're talking about like a really large data set, it's probably best to let the user kind of make that determination. So in this one, what we're doing is we are serving this directly from IndexedDB. So if we go, whoa, that's not what I intended. What is happening? How do I get this back? Does anybody know how you put this back? Yeah, I don't know why it did that.
Swipe, 3-finger swipe back.
Yeah.
Just swipe back and forth.
Oh.
You can do it with the menu. You should be able to do it with the drop-down menu. Show console drawer. No, never mind. That's not it. Anyway, just
Well,
swipe back and forth. Just swipe.
Okay, so here is our IndexedDB database. Please don't ask why it's called Death Star 2. We don't like to talk about that. Finally. Okay, so we have two object stores. We have a Stormtrooper object store and a Rooms object store. The scenario here is when you are out in space, you're running around, and you have your hyperdrive connected, your Wi-Fi tends to drop out. But you still need to know who has access to which part of the ship, even when you're at hyperdrive. And then, for the far reaches of the galaxy, there isn't Wi-Fi yet. The infrastructure just isn't there yet. So this accounts for these scenarios. If we delete our database, which everybody cross your fingers for me, and we're going to refresh, and everything's gone. So just to show you that real quick, rooms are gone. So in this scenario, we could say, go ahead and pull down our room data, and it is there again. Thank goodness. Pull down our trooper data. It is there again, because what that did was pop over into sources real quick. Does anybody hear that? Am I just hearing things? Okay, I guess I'm hearing things. Never mind. I thought I heard sirens. Okay. If I can remember correctly. So, nope, that's not it. Dang it. Okay, here we go. Ignore all the React that's going on. I thought this would be fun to write in React. The part that we really care about is this getTrooperData method and this getRooms method. Those are reaching out to an API, grabbing the data from the API, and then once that's completed, we've got this then method, this is what's actually adding those to the IndexedDB object store. What is list? Which that's happening over here. So once we get our troopers from the API, we pass them into this method, open up our database. We use that onSuccess method. We have a reference through the event that gets passed in to the actual database. We're going to map over what we got from the API and generate the objects that we need to push into the object store. And then this is where we're actually pushing those into the object store. We're opening a transaction, specifying read-write, specifying the object store, using the add method. And it's the very same thing for rooms. It's just the map is smaller. And then if we wanted to, this is the real moment of truth. If, say, we're at the far reaches on a mission, and actually in the slides it was Sally who got a promotion. She no longer has access to the trash compactor. Instead, she has access to the landing strip. We go ahead and save. And if we pop this open again, can jump over to application, look at Sally, and it now shows her with landing strip access, but she does not have trash compactor access. So the scenario here is when we were back to a place where we wanted to go ahead and sync the changes, we would use these two buttons and go ahead and sync those changes. These don't really call anything because, reasons. But if we pop these open, I remember what this is doing. And, oh my gosh. Shrooms server, where is that? I've completely lost where anything is. I'm sorry, could you repeat that? Yes, I think so. Yes, thank you. Push rooms to server, there we go. Thank you. So, again, we're not actually pushing anything to a server, but this is kind of what this would look like. You open your database, you're doing the reverse. Now we're reading records out of the database instead of inserting records into the database. But same deal, open the database, we have a reference to the database in the onSuccess function. We initialize a transaction. We use that to get all of our records. Go ahead and map those to what your object would need to look like before you push it to your server. And then we're going to utilize this onComplete function because that's the event that gets called when everything is finished with that transaction. And that's where we would go ahead and make our AJAX call. And on that note, I believe, I've lost my slides. That's cool. Okay. My slides. Anyway, that was all I had, actually. So good thing that it happened then. Are there any questions? Yes.
So you said that key path was primary key. Does that mean you can only have one per object store?
So the question was, can you only have one key path per object store? No. You can actually pass in an array of strings as your key path, but this leads to an interesting scenario. So say for this example, we made, their name and also their ID as the key path. You would have to, when you're doing your lookup, you'd have to know both of those pieces of information in order to look up the item directly. So yes, but it poses some interesting challenges if you don't know what the information is.
So you can't say, I want one for ID and one for
No, I wish you could. That'd be really nice, but unfortunately, no. What else? Yes?
Is there any data I can assume, if I'm on my phone and I'm making an update, halfway through I realize that my internet connection's gone.
Let me make sure I understand. So our scenario is we did something on our phone, but we lost connection. And then we grabbed our laptop?
Yeah, so something that had connection for whatever reason.
Okay, something that had. Oh, okay. So I'm not sure how you would hook up an event to delete the data that was on your phone, but something that you can do is like periodically, like this is an example actually from the other prototype I made. So you might notice that we're storing a date added. So that was kind of my scenario here, was like periodically go in and everything before today or last week or whatever date, delete everything. So I don't know if that would quite work for the scenario that you suggested.
It would, but I guess that's something that you're
You're manually going to have to do that.
You can see all these dates, this one's fresher, do that.
Not really. You'd have to manually set that up. So what else? How long has IndexedDB been around? I found blog posts as far back as 2013, 2014. So it's surprisingly old for how new it is, I guess. I think it's really cool. I think it's really robust. So yes, it has really, really great browser support. It's supported as far back as IE 10. It's supported in Edge as well. And there are like polyfills that you can get for anything before IE 10 as well. So, any other questions? All right, thanks everybody.